Now in the inheritance, we finished types of inheritances, and then next we started types of classes. In the types of classes, we have completed interface also. Now left over are abstract class, class, final class, inner class, anonymous class, and at last inner. Abstract class and abstract method we discuss in method consequences in Java programming structure. Class consequences we discussed in abstraction topic 3 times, and again 4th time we came here to discuss about abstract class and the significance of declaring method as abstract, class as abstract. That we discussed more comprehensively in the last abstraction topic. Hence, I don't want to declare much time on dedicate much time on abstract classes. Even final also we discussed when to declare classes final. If all variables of class want to be final, instead of declaring all variables as final, better declare class as final. Like that we discussed. If class contains abstract methods, then it must be declared as abstract. If class contains abstract method, then it must be declared as abstract. Abstract class may or may not contain abstract method. That also we discussed. Without abstract methods, why class is declared as abstract? If class do not want to be instantiated, then it is declared as abstract class. Common methods containing class is declared as abstract. For example, component class in AWT programming. There is no UI for component class, but it provides common methods to all the components. Around some 15. Set text to set Y, set width to set height, background, foreground, font, the next what you call enable, editable, visible, position, like that 15 setter and getter methods required to all the component classes are provided by single class called component class. Such a class is in public abstract also. So if class don't want to be instant, then it is okay. Abstract classes cannot be instantiated. Here is one small example, because we discussed about abstract class use in runtime polymorphism. That example we covered in our previous videos. Here one small example I am taking on abstract class and abstract method. Though generic method implementations comes from abstract superclass. If child classes want to override, then they can override superclass methods. For example, here is one class called class abstract class. Class is declared as abstract as well. We'll see why class is declared as abstract, because class is having abstract method. Because of class containing abstract method, the class is declared as abstract. What is the method name? Abstract void print. Parameter name is string name. Abstract void print. Okay. And the subclasses must implement this void print method with string name as a parameter. Okay. Understood. Abstract void print string name. After this is fine. But the abstract, along with abstract, the method is also prefixed with private. And tell me, what is the purpose of private? What is the significance of private? Private members cannot be accessible outside the class. Private members can be accessible only within the class. Private members can be accessible only within the class. They cannot be accessed outside the class. Then what to do? Is it right declaring abstract method as private? Because abstract method intention is this method should be implemented in the subclasses. If you declare such abstract method as a private, is this combination, private abstract combination, is it a wrong combination or not? Illegal combination or not? Yes. An abstract method should not be declared as private. It can be declared as default, it can be declared as protected, it can be declared as public, but abstract class, abstract method should not be declared as private. It's a wrong combination. Abstract final, private abstract, wrong combination. So you declare protected. If not private, you may get it out. Can I declare abstract method as protected? Declare it was. no problem. The protected method can be accessed both within the package and as well as outside the package up to subclass. And this protected method can be implemented outside the package and it can be implemented in the subclass within the package as well. Protected member can be both. So you declare protected abstract word print string name. So this is the correct declaration. No problem. Why we declared it as protected? Because here we are writing one subclass, public class, abstract class, subclass, extends abstract class, subclass, extends abstract class, and I am implementing the method void print string name parameter and some statement. While implementing superclass methods in subclass, there is one condition. While implementing superclass methods in subclass, the condition is you maintain method with the same access specifier. While implementing superclass methods in subclass, to the method you maintain same access specifier or increase the scope of the access, but should not decrease the scope of the access. And a protected method can be overridden or implemented as a protected or public, but not default or private. A protected method can be overridden in subclass as a protected or public, but should not be overridden as a default or private. It's a protected method. In the subclass, you write public void print. This is correct. You put it in comments. You put this line in comment. You uncomment this one. What happens? Void print string name. Here also we are declaring void print string name parameter. But here it is a protected method. When implementing protected method, same scope or the next higher level scope. And its scope must be increased or maintained same, but its scope should not be reduced. Protected member least scope is a default. So if you are trying to reduce the scope of a method while method overriding, you will immediately get one compilation error saying that weaker access privilege error. This weaker access privilege error comes because while overriding the method, we are trying to reduce the scope of the method. So while implementing abstract method, we need to keep this point also as an important point. Override abstract class abstract methods with the same scope or with the increased scope, but not with the reduced scope. That's all. Create object of the abstract class subclass and all print method pass Surya. That argument will come here and the statement will be printed. We already know that. Coming to the class. Abstract class, because we covered more about abstract class in the previous sessions, I reduced the explanation on abstract class in this example. Otherwise, I should have repeated runtime polymorphism example once again. Yesterday I took employee payroll, student admission, couple of other topics. Those examples must be repeated once again in abstract class. That's why I didn't discuss. So next coming to the topic is class. Coming to the class. A class is neither an abstract class nor a public class. Final class. It's a normal class. A class can be used in both ways. A class can be both inherited and as well as instantiated. A class can be inherited or it can be instantiated. A is equal to new A of. A class can be inherited or a class can be instantiated. A class can be both inherited and instantiated if it is a normal class. To class we can apply default and public access specifier. And whenever you write a class, don't write any access specifier prefix. By default it is default. If you are interested, you write public, then class will become public. So to class we can apply both default or public access specifier. No access modifier is applied to class by default. See, only one modifier is by default applied, or one specifier and one modifier is by default applied to class, that is to interface. Now only one modifier, sorry. To interface, only one modifier is applied by default, that is abstract. And apps interfaces are by default prefixed with abstract modifier. But coming to the class, whether you want to declare classes public or default, whether you want to declare classes abstract or final, that keyword should prefix to class. Hence, no access modifier is applied to class by default. And no public, no abstract, no final, like that. However you declare, that is how the class is. All are implemented methods. In class, you will find all methods are implemented methods. You don't find any abstract methods in the class. In class, finding methods may exist in the class, but abstract methods doesn't exist. If it exists, class will be declared as abstract. Class can be both inherited and as well as instantiated. That is correct. If a class is written with default access specifier, then during compilation, compiler will generate one default constructor in the class. We discussed this point many times previously. Suppose if you write class A and compile with Java C, A.Java, then what happens? In the class A, automatically one default access specifier, no parameter constructor will be generated in class A. During compilation time, automatically like this it will happen. Suppose if you write class B and if you compile Java C, B.Java, what happens? In the public class B, with the public access specifier, one no parameter constructor is generated by default in class B. And a default constructor is the constructor which is generated by default by the compiler, the constructor with no parameters, and its access specifier is same as class access specifier. If class access specifier is public, constructor access specifier is public. If class access specifier is default, constructor access specifier is also default. So that is what the meaning of this entire whole paragraph, Hope that is clear. Class default class int ing. If you don't write any constructor, compiler by default generates one constructor like this. Default class. In class, if you declare two variables and if you don't write any constructor by default class with the class name, one constructor is generated with no parameter with the same default access specifier. From that, superclass constructor will be called, and this is completely defaultly generated and implicitly generated code. Implicitly generated code by compiler. If you don't write anything. From the superclass constructor will be called. The two class instance variables I and j are initialized with the default values. Like this is how the default constructor is generated by compiler during compilation. If you don't write any constructor in your class. Suppose if your class is public int ij, if you don't write any constructor, compiler by default generates one public access specifier, one no parameter constructor. From here also superclass constructor will be called and I and j instance variables are initialized with 0. And based on the class access specifier, the default constructor generated access specifier also depends on that. Good, next. Here I am writing one more class called another default class int ing. No default constructor is generated by compiler if you write constructor on your own. Here in one class I declared two variables I and j. So in this class, if you explicitly generate one no parameter constructor, then default constructor generation is, possibly sometimes. Okay. It's enough. Here I am explicitly writing one no parameter constructor. In this no parameter constructor, you know what happens? Superclass constructor will be called I and j instance variables are initialized to 0. Suppose if you write one two parameter constructor with int a comma b, and if anybody creates object of another default class adc is equal to new another default class of 10 comma 20 like this, don't like this. This 10 and 20 will come to this a and b. This a will be assigned to class instance variable I. This j will be assigned to class instance variable j. That these two constructor parameters will accept two arguments from client like this. And these parameters are assigned to class instance variables. Okay. So a class can be now created with no argument constructor or created with a argument constructor also, two argument constructor also. Okay. Then here it is another default class subclass. Another default class subclass. This class subclass extends another default class. Int k and l, I, j, k, l, k, l. Here one no parameter constructor is written, explicitly written. So SOPROF calling is common. So because of if SOPROF is called, superclass ij variables will be initialized to zeros by default. And k is equal to 0 and l is equal to 0. This also implicitly happens. Suppose if you write two parameter constructor in subclass here. Now how many variables the subclass is having? Two variables on its own. Two variables ij are coming from the superclass. K and L are the two variables of this class. So in this class, if you write a constructor with two parameters, the first two parameters should be supplied to superclass variables. If any extra parameters comes, with that, our local class instance variables must be initialized. And if you get only two parameters, int a comma b, these two must be immediately passed into superclass constructor. That means here. And if anyone creates another class, another default class, subclass, class object A, D, C, S, C. If anybody creates object with 10, 20, then what should happen? This 10, 20 should come here to the subclass constructor. From here, the two arguments should go to superclass constructor. First superclass two variables should be initialized, I and J. If any extra parameters exist with that, we can think of initializing our class instance variables. Suppose if you write a 4 parameter constructor A, B, C, D, A, B can be passed into superclass constructor so that with that ij variables will be initialized. And C and D are left. The C and D are assigned to K and L. And if extra parameters comes, with that you initialize your class instance variables. But primarily whatever basic number of parameters you are getting, that you pass into superclass constructor so that you make sure superclass variables are initialized first. If nothing is passed, you call no argument superclass constructor. Your variables are 0, 0. That superclass variables are also 0, 0. Nothing will happen. See here. This is another class. This class name itself is another default class subclass. Another default class subclass. To this class we are writing one more subclass called D. Here ij, kl, mn. Two variables are declared as mn. In the first superclass ij. In its immediate subclass ij, kl. In this class mn. So you tell me in this class, if no parameter constructor is written, superclass no parameter constructor will be called. If two parameter constructor is written, superclass two parameter constructor is called. These two I and j will be initially passed here. Suppose if 4 parameter constructor is written in D class, into superclass constructor 4 parameters will be passed so that this AB will go and initialize ij and CD will go and initialize k. And in this class, if 6 parameter constructor is written, I, A, B, C, D, A, B, C, D will go to superclass constructor. From here, two variables will go to two parameters will go to superclass instance variable initialization. Two variables will initialize another default class of class variables. And two more variables are left, E and F. Two parameters are left, E and F. They will initialize this D class variables. And this is how, first of all, whenever your subclass gets any parameters, first you supply them to superclass constructor. If left, with that you initialize your class instance variables. Okay. First you always give preference to superclass instance variable initialization first. Then about final class. We already know about final class because final class is a class when final class cannot be derived. Final class can be instantiated. When final class can be returned. Suppose if class contains 10 variables and if five variables want to be final and 5 methods. Sorry. If class contains 10 methods, 5 methods want to be final and 5 methods want to be non-final. Then you declare first 5 methods as final and remaining 5 methods as normal methods. Then what happens? A class can be derived in the subclasses. Final methods cannot be overridden. Remaining 5 methods can be overridden. Suppose if you want to declare all your class methods as final, instead of declaring all the methods as final, allowing your class to inherit. But in the subclass, none of your final methods can be overridden. So instead of allowing user to subclass from your class, if you declare class itself as final, your class cannot be derived. None of your methods can be overridden in subclass. Simple. That is how class which contains all methods as final methods can better be declared class as a final instead of declaring methods as final. That is the conclusion about final class. That you can do later on. Coming to the inner class. Coming to the inner class. Inner class is one of the important class in the object-oriented programming. In some complex APIs like collections, user interface programming, swings, and the next, collections and user interface programming swings, we found inner classes more, but we can also write our own inner classes. Okay. So what do you mean by inner class? Writing class inside a class. Writing class inside a class. Class A started here, its body ended here. This is class A body. Class B, we started here, we ended here. Class C extends A. How C is different from B? C is a subclass of A, but B is an inner class of A. B is written inside a class. Here C is written outside a class but by extending from class A, C was derived. So C is a subclass, B is an inner class. So writing class inside a class is called as inner class. Writing class inside a class is called as inner class. In my view, if you write a class inside a class, in my view, what are the two members of class? Variables and methods are the two members of class. Class members and variables, constructors, methods. I'm sorry. Variables, constructors, methods are generally treated as class members. If you write one more class inside a class and an inner class, nested class. If you write inner class or nested class, then this class also becomes a member of the class. Like variable, constructor and method, the inner class also becomes a member of class A. Because of inner class becomes a member of outermost class, inner class, and a member of a class can be private, default, protected, public by default. All 4 access specifiers can be applied because same we can apply on the variables, constructors and methods. So inner class can be private, inner class can be default, inner class can be protected, inner class can be public. Point number 1. Because it's a class, it can be final, it can be abstract by nature. In addition to abstract and final, an inner class can be static also. Like how variables are static and methods are static, an inner class can be static also. And an inner class can be private, an inner class can be default, an inner class can be protected, an inner class can be public, an inner class can be abstract, an inner class can be final, an inner class can be static. And in a class we can write both static inner class and as well as non-static inner class, isn't it? Okay. See this example carefully. Here we are having, this is one portion, this is another portion, and this is another portion. 1, 2, 3. In this portion 1, and I'll explain about this outer class points once after completion of the example. Then you will get a clarity on the explanation. Here I am writing class called class OC. OC means outer class. Class OC. In the OC, I declare two variables, int I and static int z. Int I, it's an instance variable. Static int j, it's a class variable. Okay. When I found non-static variables and static variables, one important point came into my mind, because I came from the methods explanation previously. One point I remember, the point is static variable, non-static, two variables are there. Similarly, we are having one static method and non-static method also. But point is, into static method, which variables can be accessed? Into static method, is static variable can be accessed or not? Non-static variable can be accessed or not is the point. Static members can access only static members, that is the same. And the static methods can access only static variable but not non-static variable, because static points to class memory. That method can point only to class variables that exist in class memory only, but not in instance. See, forget about all that. A static method can access only static variable. It cannot access non-static variables. But a non-static method can access both non-static variable and as a static variable. Because non-static method can access its instance memory variable and as well as class memory variable also. And a non-static method can access both instance variable and as well as class variable. Non-static variable as well as class variable. There is one. Is it a static or non-static method? A non-static method. Here both static and non-static variables are accessed. It's a static method. Non-static variable cannot be accessed, only static variable can be accessed. Done. This part is over. This part is over. This part is over. That part is over. Next, we are continuing the same outer class. We are continuing outer class. We are continuing outer class. We are continuing outer class. We wrote one class called, it's a inner class. Sorry, not subclass. It's an inner class. Nested class. Class NSIC. NSIC means non-static inner class. I just named class with that name. Non-static inner class. Non-static inner class. Class non-static inner class. Is it a static class or non-static class? It's a non-static inner class. We said non-static. Okay. In the non-static inner class, we can write both non-static methods and also static methods. Okay. In non-static inner class, we can write both non-static methods and as well as static methods. In non-static inner class, we can write both non-static methods and static methods. But in both the methods, we can access and in this, non-static inner class, non-static method, we can access both static and non-static variables of outer class. And coming to the static method, we can access only static variable of outer class. In my case, in non-static method and static method, in both only static variables can be accessed, I think. This non-static method cannot be accessed. Yes. Is it true? Or vice versa? There, both methods you can write, only static variables can be accessed. Alright, correct. In non-static inner class, non-static method, you can access both non-static and static variables of outer class. In static method, we can access only static variable of outer class. That is clear. Coming to the static inner class, this class is also containing in the same outer class. Static inner class, SIC. Both non-static and static methods we are writing. In the non-static inner class, we cannot write static method. We can write only non-static method. Non-static inner class can contain only non-static method, in which both we can access static and non-static variables. We can't write static method. In non-static inner class. In static inner class, we can write both non-static and static methods, in both of which we can access only static variable of outer class. Okay, this is clear. In non-static inner class, we can write only non-static method, in which we can access both instance variable and as well as static variable of outer class. We cannot write static method. In static inner class, we can write both non-static method and as well as static method. In both, we can access only static variable of outer class, but not non-static variable. That's all. Clear. Right. And these are all already implemented examples. That is clear. So what to write and what not to write inside static inner class and non-static inner class are very clear. Static inner class allows us to write both static and non-static methods as well, but we can access only static variables of outer class. Non-static inner class will allow us to write only non-static method but not static method. Here both non-static and static variables of outer class can be accessed. Then how to instantiate and use these classes is a point. Come here. First you create object of outer class. And call the print method. Print method is a non-static method called. Then we want to call static method. Class name dot method name. Done. Then point is how to create an object of non-static inner class and access its non-static method. How to create object of static inner class and how to access its non-static and static methods. And first of all, we should know how to create object of non-static inner class and static inner class. This is very, very important. See, if you want to instantiate non-static inner class, how to create? First, outer class object is created. Outer class object is already there. So you write like this: outer class reference dot oc dot and outer class name dot non-static inner class, because it's only a reference, no? Outer class non-static inner class is equal to, while creating object, this is the first time we are seeing like this. Instead of writing new non-static inner class, this new must be prefixed with outer class object reference. oc dot new non-static inner class we have to call. Here outer class name dot non-static inner class name, some reference is equal to outer class object dot new non-static inner class constructor. Object is created, non-static method is called. And this part is over. Object creation and this method invocation is over. How to create static inner class? Then to create non-static static inner class. To create static inner class directly, class name dot static inner class reference is equal to new outer class dot static. Here you can use outer class object reference or directly outer class name also, oc dot sic, because static inner class is a static member. So oc dot sic. So static inner class object is created. With that object, non-static method is called. With this static inner class object reference, printf method is called. And coming to the print6 method, because it's a static method, we can call oc.sic, static inner class, sic.print6. Directly method can be called. Print6 method can be directly called with outer class dot static inner class dot method name. Non-static method of static inner class can be called with first create object of static inner class, then with that object you call its method. That you have to write as oc.sic. oc.sic. So with this, the inner class concept is completed. One more topic, anonymous class. Anonymous class, in types of classes, anonymous class, enum are left. That completes inheritance topic. Then method overloading, method overriding. The topics in polymorphism we have to cover. Pass by value and pass by reference in message passing. That one more topic we need to take. Probably we could complete the remaining topics in next one more video. Until then, we will end up this session. Goodbye. Thank you.
Like, share and subscribe. Hit the bell icon for more updates.